Now we're ready to start Chapter 6, which is our study of circles. Now, circles are not polygons. Polygons are multi-sided closed figures, and the sides are lines. Circles do not have lines. In fact, the definition of a circle is it's the set of all points equidistant from a fixed point. And that fixed point would be called the center. And normally we do mark the center of the circle with a name, uppercase letter, and that's actually the name of the circle. So there's Circle K. So here we're just going to get started with some vocabulary. The circle is named by the center point, so this circle would be Circle P. And the symbol for circle is that circle with the center point in it. Now here we have points A, B, C, and D, and they are considered on the circle. They are one of the points that are equidistant from the center. But you can also have points on the exterior, like point D and point H, G and H are exterior, or like point R, which is interior to the circle. You can have points in the circle, on the circle, and out of the circle, outside the circle. Now, an important measurement in a circle is the distance from the center to the circle, and that is called the radius. And all radii is the plural of radius, all radii are congruent. They're the same distance from the center to the circle. That's part of the definition of a circle, is that it's all the points that are the same distance from the center. So we could say SQ is congruent with TQ. Segment SQ is congruent with TQ, or we could say the length of SQ is equal to the length of TQ. Remembering, congruence talks about figures, equal talks about lengths or measurements. So here we have the statement that all radii of a circle are congruent. Now there is one special property of a circle. We'll call this circle R, and that is two radii together in a straight line. That's called the diameter. So the diameter is equal to 2 times a radius measurement. In fact, any line segment that connect any 2 points on a circle are called chords. The diameter is a special chord that actually contains the center point. Now, circles can be congruent. What does congruent mean? We've said it so many times. Same shape. Well, all circles do have the same shape. Same size. So circles are congruent if they have congruent radii. If this is 2 centimeters and the radius of this other circle are 2 centimeters, then we would say that these two circles are congruent because they have the same shape and they have the same size. Here are 2 circles. They're concentric circles because they actually have the same center point. So here's center O. O is a very common name for a circle. It kind of comes from origin, like origin is the center point of the XY coordinate system. So that's a lot of times why you will see O as the name of a circle. It is not a 0, it's the letter O. So here are two concentric circles, and they share a center 0. So we've talked about points being in, on, or outside the circle. We've talked about radius, chords, diameters, concentric circles. And now we're going to talk about another measurement or characteristic of a circle, and that is the arc. The arc is the measurement on the outside of the circle. Now, for radii, for diameter, you could take a ruler and actually measure it if you wanted, because they are straight lines. Arcs are not straight lines. So arcs are named with the arc notation above. And so here we have figure 6.5, and here we have the diameter AC, and we have the points on the circle, point A and point B. So you can see arc AB is highlighted, and that is the distance of the arc between the points A and B. So if we're referring to that arc, it's going to be the arc AB, like that. If we're talking about the measurement of the arc, that's going to be the measure of arc AB. This is talking about the arc, this is talking about the length of the arc. Two different notations. Now, arc ADC, since it is the arc formed by a diameter, arc ADC is considered a semicircle. Semi meaning half. Semicircle. And we're going to put the middle letter of the point for clarity. If we mean this arc, we have to include a center point to distinguish it from this other semicircle on the other side. It's kind of like with the angles. If there could have been misunderstanding of which angle you're talking about, you include a second. So I wouldn't just say angle A, I would say angle CAD. You include more names of points to be concise. So this is a semicircle. If a semicircle is smaller, if an arc is smaller than a semicircle, it is called a minor arc. And then if a semicircle is, if an arc is bigger than a semicircle, it's called a major arc. Another measurement is the central angle. And a central angle is an angle whose vertex is the center of the circle. So here we have angle NOP. Angle NOP is considered a central angle, or it was also called angle 2. Angle 2 would be considered a central angle. So would MOQ, so would QOP. We've got several central angles in that diagram. The intercepted arc of a central angle is determined by the 2 points that touch on the arc. So in this picture, well, I'll go ahead and create one here. In this diagram, and if I have point N and point P on my circle, angle NOP is a central angle, and the intercepted arc is the arc NP. And what we're going to find is they actually have the same measurement. We measure angles by degrees, and we're also going to be measuring arcs by degrees. So let me go ahead and clarify here. If this was a 37-degree angle, we would say the measure of arc NP would also be 37 degrees. So let's look at this example and let's see if we can find some of these measurements. O is the center of the circle. Name all 4 radii. So we have OM, OQ, OP, and ON are all the radii. Name the diameters. Diameters are a chord that go through the center. So for B, our radii would be QN, and the chord or the segment NMP. C asks us to name all 4 chords. Well, we have the 2 we've already named, which are also happen to be diameters. And then I have this chord here, QP, and this chord here, NP. Those are all 4 chords in that circle. Name a central angle. Any of the angles that have O as its center. So I'll say angle MOQ is a central angle, but there are actually several of them. Name a minor arc. That's an arc that is smaller than a semicircle. So I'll say, how about this one? There are several of them, but I'll say arc QP is a minor arc. Name one semicircle. All right, well, I'm going to have to use the diameter. Let's say I'll use this diameter, and I'm going to go this way around the circle. So I'm going to say arc QMN is a semicircle, and I'm going to include the M, so I'm saying that I'm talking about this side of the circle. Name a major arc. That's an arc that's greater than a semicircle. So let's say if I start here and go around and end here, that would be considered a major arc. So I'll say P, N, M, Q. I could have just said P, N, Q, just to say I'm going around that circle. What is the intercepted arc of the angle MON? What is the intercepted arc of the angle MON? It is the arc MN. And what is the central angle that intercepts arc NP? That's this angle right here. I think I'll just make it easy and say angle 2. Or I could have said angle NOP.